Good morning, one and all. Today, we are going to see a small problem on economic load dispatch problem. Take this problem. For a generating unit, the fuel input in millions of BTU per hour. Okay, that is MBTU per hour is expressed as a function of the output PG, that is in megawatts, by 0.032 PG square plus 5.8 PG plus 120. So this is the fuel cost function. Determine what we need to determine is first one is the equation for the incremental fuel cost in dollars per megawatt hour as a function of PG in megawatts based on a fuel cost of $2 per million BTU. Next, we need to determine the average cost of fuel per megawatt hour when PG is equal to 200 megawatt. Next, the approximate additional fuel cost per hour to raise the output of the unit from 200 megawatt to 201 megawatt. Also find the additional cost accurately and compare it with the approximate value. So first what we need to determine is we need to determine the equation for the incremental fuel cost. So the input curve in that input curve in dollars per megawatt hour that you know. So what is F given in the problem? That is heat rate or F given in the problem is 0.032 PG square plus 5.8 PG plus 120. And the fuel cost also they have given us $2. So what we need to do is this into this $2 that will gives you the fuel cost function. So fuel cost function after multiplying with the $2, so we'll get the fuel cost as 0.064 PG square plus 11.6 PG plus $240 per megawatt hour. Next, they asked to determine the incremental fuel cost. Incremental fuel cost means fuel cost is there. So incremental fuel cost is nothing but lambda. That is nothing but we need to differentiate with respect to PG. That is the fuel cost. We need to differentiate with respect to PG. That is the incremental fuel cost. That is equal to lambda. So here DF divided by DPG is equal to. So we need to differentiate with respect to PG. We need to differentiate this equation. That is 0.064 PG square plus 11.6 PG plus 240. While differentiating, you'll get the answer as 0.128 PG plus $11.6 per megawatt hour. This is the incremental fuel cost. Next, we need to find out the average fuel cost that is asked in the problem. Average fuel cost when PG is equal to 200 megawatt. Average fuel cost in the sense whatever the fuel cost divided by that PG. That is the average. So F divided by PG, that we are substituting PG as 200 megawatt. So here, what is F? This is the F, that is 0.064 PG square plus 11.6 PG plus 240 rupees dollars per megawatt hour. So here, so F divided by this PG, that is 200. Okay, so that is the average fuel cost. So we need to substitute PG is equal to 200 here. So just substituting 200, that is 0.064 into 200 square plus 11.6 into 200 plus 240 divided by 200. That is average fuel cost divided by 200. So that will gives you the average fuel cost. So that simplifying, we are getting the answer as $25.6 per megawatt hour. This is the average fuel cost when PG is equal to 200 megawatt. Next, what they asked next, is determine the approximate incremental cost for additional 1 megawatt. Additional 1 megawatt, that is from PG is equal to 200 megawatt to 201 megawatt. So what is the approximate incremental cost that we need to find out? Incremental cost for this, that is PG is equal to 200 megawatt to 201 megawatt. So differentiating DF divided by DPG by taking PG as 200. So what is this? So this is the cost, like incremental cost. So while differentiating by substituting PG is equal to 200, so already differentiated value given in the problem, or otherwise you need to differentiate it again. So while differentiating, we'll get to the answer as, say, yeah. So this is the differentiated value, that is 0.128 PG plus 11.6. So in that, we need to substitute PG as 200 megawatt. So after simplifying, we are getting the answer as $37.2 per hour. This is the incremental cost while taking PG as 200 megawatt. Now they are asked additional fuel cost from 200 megawatt to 201 megawatt. So what we need to do is we need to differentiate simply this DF divided by DPG. We need to differentiate with respect to 200 megawatt to 201 megawatt. So while differentiating, differentiate, what we need to do is we need to just whatever the value here, that is 0.128 PG, that we need to integrate. That is 0.128 PG squared divided by 2 plus 11.6 PG. Okay, so that differentiation becomes integration. So we need to what we need to do is this value we need to 0.128 PG squared divided by 2 is the differentiate like integrated value, plus 11.6 if you differentiate, if you integrate this, that is 11.6 into PG, we integrate this, that is 11.6 PG will come. So now what we need to do is we need to substitute 200 and 201 here. Okay, 200 and 201. Upper scale is 201 megawatt. Downward scale is 200 megawatt. Just we need to substitute this. So while substituting this is 201. We are going to substitute here. That is 0.064 into 201 square plus 11.6 into 201 minus this 200 we need to substitute, that is 0.064 into 200 square plus 11.6 into 200. So just simplifying, we are getting the answer as 4917.264 minus 4880 we are getting. So just so simplification, we are getting the additional cost as $37.264 per hour. This is the additional cost from 200 megawatt to 201 by shifting the generator to 200 megawatt to 201. That is $37.264 per hour. Like that, you need to solve this problem. Very simple problem, they may ask in some 5-mark question like that. So here what they ask, first you need to understand the question clearly. Determine the equation for the incremental cost in dollars per megawatt hour. So equation first we need to, dollars, like whatever the fuel cost, that also given. So you need to multiply and we need to find out the incremental fuel cost. That is DFI, DF divided by DPG. Next, they ask average fuel cost when PG is equal to 200. So this average fuel cost, whatever the fuel cost divided by that particular generator, that is generator size. So that is 200 megawatts. So that you need to substitute and you need to find out the average fuel cost. Next, we need to find out the approximate incremental cost. Okay. First, we need to find out the approximate incremental cost by taking PG is equal to 200. That cost we are finding out. Next, we need to find out the additional fuel cost from 200 megawatt to 201 megawatt. That is the additional fuel cost. What is the additional fuel cost? That also you need to find out. Just we need to integrate that equation. There is DF divided by DPG equation. We need to integrate. So while integrating, we are converting this and substituting. We are finding out the additional cost from 200 to 201 megawatt as $37.264 per hour. Like that, you need to do it for this particular problem. Thank you.